Hello and welcome to episode 3, part 2 of the Trusted Tech Talks Serverless podcast with me, Lloyd Lowson, and my guest speakers from InfinityWorks, Calum Dickson, Adrian Hesketh and Ben Foster. Today we will be continuing on from the previous episode, discussing a variety of key topics surrounding serverless technology.
So we've been talking a bit about serverless, and we've mostly focused around, I guess, web APIs and web applications, right? But that's not the extent of serverless, is it? And I think, a lot of customers are using it for data processing pipelines and for dealing with vast quantities of streaming data. So what might be sometimes, or what AWS calls Clickstream Analytics. So I think, we're working with some pretty big retailers who are pushing a lot of their click data about, what customers are hovering over, what customers are doing on the site, and are typically processing that with AWS Lambda and SQS queues and all that kind of stuff. A huge amount of flat file processing as well, daily dumps and those kind of things. So I guess those are, I guess, also serverless applications.
Yeah, I guess I've not.
Is that what you do? Is that what you're doing?
I've not been lucky enough to work with the real-time streaming aspect of serverless data. I think the instances I've looked at have been more, I guess, more ETL, more traditional batch. So it's been glue jobs, perhaps using Athena for interrogation of data in S3, and so I guess that side of the ecosystem, which still got a lot of very useful functionality, but yeah, I don't have as much experience of the exciting real-time stuff yet.
Athena's pretty new, isn't it? It's only, is it a year, 2 years old now? It's got to be around that period, hasn't it? It's only a couple of years old, is it?
Yeah. I'm not sure. I think I certainly picked it up for the first time maybe 2 years ago. I'm not sure how long it had been in existence prior to that, but it's definitely become a useful tool in terms of just, okay, well, I've got data in S3 and I want to immediately pretend it's a database, and being able to work with that in a kind of similar vein as I've got this code and I want it to run somewhere with as little required lead time as possible. So I guess in a sense that is very much still serverless.
I think five years ago, I started building a project in a serverless project, and the choice, I know it was 3 years ago, and I chose to use a relational database over DynamoDB because I wasn't comfortable that I could query, get the data out and query it in enough forms. And I think there's many reasons why that was. I mean, ultimately, I wasn't completely convinced about what the data model would be, and what the right structure would be, and I was a bit frightened about at the time, mostly due to my, I guess, inexperience with DynamoDB, but also due to the feature sets. But now this ability to be able to say, well, actually, I'll just hook up DynamoDB streams, push that through a Kinesis Firehose, let it land in S3, and then I can query it using Snowflake or Athena. It's just all of those kind of issues that led me to sort of sticking with what I knew around relational databases have kind of just evaporated, because I can still create those relational reports and sort of get data from disparate microservices in a way that I couldn't, for 3 or 4 years ago. And I think it's been interesting how, serverless isn't just Lambda, is it? It is the whole ecosystem that you bring to bear on it.
And it's kind of encouraging you from using good architectural patterns as well, such as breaking up your operational and your analytical data stores too. Is just by the nature of using things like DynamoDB streams, it's encouraging you to do that a bit more.
Yeah, I guess that's almost. Sorry, go on, Adrian.
Go for it.
I guess that's kind of similar to the cost of ownership discussion, right? Because there's if you're just paying for the data crunching, then why not have one system do your transactional data crunching, another half do your analytical, and just choose the right tool for the job and pay for what you use there, rather than say, okay, we've paid for these SQL Server licenses, so we're going to use it for everything because we're not paying for another tool on top of that. So it all ties in.
Yeah, I think that's a good point. When you've got a large cost of trying something new, then it makes you stick with what you've got, because you don't want to try something new because, well, what's the point? Because you you can't afford it for just that tiny single use case. But when you've got this kind of pay-as-you-go model, you're able to sort of experiment a lot more fluidly, because the cost of trying something out is much lower than it was. Now it's your developer time. How much time do you want to invest? And I guess that's part of the problem now, isn't it? Is you've now got, I think, what AWS has 150 services. Last few years they've published, haven't they? They're saying, hey, we've done 2,000 releases this year of new functionality or services, and I think we're year 3 of that now. So if you think about it, that's 6,000 accumulated changes in the last 3 years of services. When I think about how much the serverless landscape shifted, Amplify is new, right? You've got the GraphQL services. You've got Athena, like we were just talking about. Huge number of changes to Lambda itself. The new API gateway, Event Bridge is new. And a lot of changes in the observability space there around how X-Ray works, and things like CloudWatch Log Insights is new. So huge number of new services along the way, which I guess makes it difficult to understand for newcomers. Where should I focus my attention? So
it's definitely a breadth rather than a depth. To Ben's point about RabbitMQ and all the complexities in terms of mastering that system, versus having the breadth to know just enough about each part of the Amazon ecosystem to know what the right tool for your current use case is, and also the conceptual issues on top of that. So more of the architectural concerns, how to actually build out these systems. I guess that becomes much more part of the engineer's domain, but they don't have to go quite as deep into the low level of each individual component.
So you said earlier you were dealing with SFTP. So you're running your own SFTP server with your customer there.
So we are actually using, we are currently exploring SFTP through AWS Transfer Family. I think they're using both currently right now, because there's a big cost to moving various third parties over to the new landing zone. But for new incoming files, we're exploring using Transfer Family, and it is fantastic, because your data is immediately just in S3, and you can continue in a serverless manner from there on. So it's a very typical enterprise use case, very effectively interfaced into a serverless architecture. So it shows just how close to the edge you can take these things.
Yeah, I think it's that $200 a month or thereabouts for the transfer product.
Something like that. Nothing huge. It wasn't me that set it up for the first time, so it was a made decision by the time I came onto the picture. So
I mean, I just introduced it into a client recently, because we had a client that couldn't integrate with anything other than SFTP for various reasons. So like, with a heavy heart, we're like, okay, we're going to have to introduce SFTP server just for you. and I was like, $200 a month though, just because you can't run a script. It saddened me a little bit, I will say.
I had to do something similar for a client a couple of years ago, before the likes of AWS Transfer and everything else was on the scene. And we ended up using a SFTP server that ran in EC2, but backed off with S3 storage. And we used some kind of proprietary file system driver that wrote everything direct to S3. Which
you basically built Transfer Family.
Yeah, basically, yeah. But it then meant that we got all the advantages of using S3, so the availability and the redundancy, but then we could also drive events off of it as well and trigger various actions.
That sounds like a good product, but it's been ruined now. Now no one will ever use it, right? So I mean, surely that's as an independent software vendor, then what's the hope now? Is it do you remember the years where you could think about founding a software company and earning the big bucks? Do you think AWS will just eat your lunch now as soon as you get enough market share? They'll just create something that's just good enough to not need your product?
It's definitely something on a micro level that I've experienced as an internal software engineer, is spending a good bit of time on a component very nearly getting it live or just getting it live, and then Amazon just releases what you've built as a service, and you've, as a very heavy heart, you just throw out your code because there's no point in maintaining it anymore, and you move to Amazon's thing. So, well, that was a nice exercise in futility, but at the same time, it is better moving forward for maintainability. So it's very bittersweet. I can only imagine that amplified tenfold if it's your business that's in question, not just your last sprint's work.
Amazon are sort of addicted to the big release, aren't they? They love a big showy release at reInvent, right? You know, the reInvent's coming up next month, and you know there'll be a whole bunch of releases. But you know, now everything's under NDA, no one's allowed to know anything about it. But like you say, that sort of macro level kind of thing is happening right now, where there's people all over the place trying to sort of build things that just kind of do a thing, and Amazon's just about to release something that does it. I think there's a really strong argument for just not doing anything, isn't there? Like now, if you see a problem with an Amazon service, you know, you should probably just wait for it to be fixed. Like, you know, when I saw the Lambda timeout, you know, the Lambda 10-second stuff, I was like, well, eventually it'll get fixed, right? And I think there was a similar one around, you never used to be able to tune the TLS parameters for API gateway. So you had a pretty permissive set of TLS certificates. And I was like, you know what? I can't be bothered to create. I wrote the code to create a CloudFront distribution, and I just thought, you know what? There's no point. I'll just wait. And you know what? Sure enough, 6 months later, Amazon released a change that allowed you to sort of tweak the parameters, and away I went. You know, and that's it. I was like, thank goodness I never bothered wasting my time on that stuff. So yeah, maybe there's a good argument now for not doing the necessary work, but guessing how big of a problem it's going to be and working it out with Amazon. That's going to be difficult because they don't publish roadmaps, do they? They're not that kind of company.
I think it's an interesting balance though, like you mentioned, Adrian, is that sweet spot between AWS building something which is just good enough and whether or not that can pull kind of people away from the other markets in which they've already got products in. So a good example of that springs to mind is AppDynamics as a monitoring platform. I've worked with a number of clients that use it and they utilize it quite extensively because they specialize in that area. It is an application performance management tool, and you know it does a really good job of all of that. And then AWS come along with their cloud watches and their X-rays, and they try and steal a bit of market share from them. But because they don't necessarily specialize, or they don't specialize yet in that area, I think AppDynamics still has quite a big stronghold there. But there does seem to be some demonstration of AWS wanting to collaborate more with vendors like that. So the Lambda extensions tooling that's come out now has pretty much opened the door for AppDynamics and New Relic and people like that to integrate a lot deeper with AWS Lambda. One of the challenges that we had previously was if it doesn't run in AppDynamics, I ain't interested in it, whether or not it's going to save me thousands of dollars and allow me to be more agile and deliver value earlier. If it doesn't work with my monitoring platform, I ain't interested. Whereas these days now, with the likes of the Lambda extensions functionality, it's opening doors, I think.
I saw a really great demo of an observability tool called Fundra with a TH. I can't pronounce TH, so it's going to be Fundra for me. It's my Lancastrian upbringing. But I saw that being able to step through a past execution of a Lambda function in a debugger window, and I thought, wow, that's the first time I've seen something like that. And you know, I think that's the future. I think of what we're going to see inside Lambda. You know, AWS has been making some interesting hires in the observability space. You know, I think X-Ray was a bit of a step forward, I think, and you know, CloudWatch is pretty good. To see what happens next will be really interesting. But like, have we got a reduced window of opportunity as you know, with all these tools? Like, you know, I can't imagine for me, like for instance, CloudWatch and X-Ray are plenty for me. I mean, I'm not really that interested in line of code performance. You know, if I really need to see that, I'll just whip out a profiler locally or run a benchmark into my unit tests and sort of understand what's going on there. Like, you know, inside my process, it's just CPU, it's going to be pretty obvious where my CPU is being wasted, and network hops are observed anyway. So I'm not really sure what how much better it has to be in order for me to be useful. But I guess, do you use a debugger day to day? I don't really.
Not so much. Sorry, Calum.
I was gonna say I did in my last role, but I think there was quite a lot more emphasis on the code, the kind of proprietary algorithms that we were running inside our lambdas rather than necessarily a complicated architecture. And maybe that's because we weren't cloud native enough. But I found myself debugging, as you say, the Node.js code locally or the Python code locally quite a lot. But definitely in the products I'm working on just now, it's very much more reasoning about the cloud infrastructure. And so the debugging is the Lambda code itself is a lot more trivial in many cases. So yes and no.
Yeah,
I did see.
Oh, sorry, go on, Adrian.
I did see a developer write some code, and then they wrote it on the computer, pushed it into the Lambda, and it was timing out. And they're like, "Why is it timing out?" And like their computer was like an absolutely top spec Dell XPS, with all of the additions, maximum memory, everything. And you're like, well, the single threaded performance of a Lambda isn't as good as your computer. And then you look at your code and you're like, yeah, I can see why that's taking a long time in Lambda. It take a long time anywhere except your computer, because your computer's so awesome. But yeah, is that a problem necessarily? I mean, I don't know.
I think there's new paradigms for people to be aware of. Is one of them, for example, is the performance that you're going to get from running your code in Lambda is not necessarily the one you're going to get on your high-powered developer machine. And we've all got these high-spec Dell XPSs, MacBooks, whatever, because previously we were writing applications that were going to sit on some really beefy tin, because coming back to our ownership and our costing models, that's how we've previously deployed stuff. It's always been on this single beefy server, whether that's SQL Server or something else. Whereas these days, it's not so much the case. We're looking more horizontally scalability than we are vertically. So that's a consideration, I think.
Having said that, I only bought a new laptop this year because I needed to use Microsoft Teams with the client, and I needed the extra CPU just to run Teams. I was quite happy with the
a dedicated core.
Honestly, I had a 2015 MacBook Pro, 13-inch one. It was perfect, no problems at all. But trying to run Teams and anything else at the same time, just an absolute disaster. So yeah, COVID has cost me a new computer. So shame.
Good. I mean, there's a question that's I've had on the previous podcasts and events that I've done, and it's kind of thrown out there at the moment. But how does serverless impact the sort of DevOps environment, the kind of way of working?
I think it definitely opens the. Sorry, go on, Adrian.
Go ahead.
We're all too polite here, aren't we?
It's difficult when you're not in person. You don't have the subtle cues as to I'm going to speak now. Everyone's just another challenge of COVID. So I think it definitely serverless in that it lowers the barrier to entry for infrastructural concerns, makes the idea of being a full stack team far more achievable. Where previously if you needed to have development teams and operations teams because the breadth of the work required is too great. But now if you are working in a fully serverless stack, then it's very much possible to have a handful of engineers or even one engineer that owns a product from inception through to production, including the maintenance, the monitoring, being on call for that product, and getting the benefits in terms of autonomy and agility and ownership of that product that you get from having that full stack responsibility. And then it's a question of, well, do you have a DevOps team, or is DevOps just a discipline that you include in your teams? And maybe you have SMEs or centers of excellence for that set standards or best practices for your organization. But ultimately, the DevOps is work that's done as part of the engineering work of each vertically aligned team. I think that's often the pattern that is most effective for organizations in terms of velocity of delivery and empowership. Empowership, that's not a word. Empowerment.
I think what I've seen is a difficulty around the security boundaries and the responsibility in that way. So when the serverless tools like serverless framework, for instance, sort of indulge you into this kind of serverless create, serverless deploy, and it kind of assumes you've got full admin rights to create anything you want inside the AWS infrastructure. And then when you come to try and do a CI/CD deployment of that, the easiest thing for you to do is to create a super user account, basically chuck that into your CI platform, GitHub Actions or Circle CI or whatever. And basically you've just given Circle CI full administrative privileges over your infrastructure, including in some cases your production environment. And that can be a problem because tools like Circle CI also allow you to SSH and just get a shell access and just basically be able to do whatever you want inside that AWS infrastructure. And I would say it's not easy to solve that. So I think in some cases what we've done there is done things like made the CI platform responsible for delivering a binary, and then using tools like code build to do the infrastructure inside the AWS world. And that goes some way to resolving it. But at the same time, you've still opened this gap because you can commit any code you like as a software engineer into the Git repository. And when you've got these kind of automated pipelines, it's just flowing straight through. So unless you've got some of the controls in place around having review before merges to master take place, and then also having like secondary checks on things like additional IAM roles. So it's very easy, for instance, to open up permissions much wider than perhaps you expected. So I think things like permission boundaries and so on have sort of recently been introduced, or in the last few years, which kind of make that possible. But it requires some pretty in-depth knowledge of how AWS infrastructure works in order to be able to sort of achieve those security improvements. So I think there's a long way to go in any kind of AWS environment, really, around making that easier to achieve. But I think it's more pronounced, I think, in the serverless world, because almost every change that you're making results in an infrastructure change. You're running every function generally needs some access to another AWS service, which involves making an AWS IAM role, which means you've got some permission to create roles, which is a kind of traditional or very easy to exploit what's called privilege escalation vector. So it's difficult, I think, to really secure that stuff well. It takes some experience there, I think.
Yeah, definitely. And they're both patterns that I've kind of grappled with recently. I think we were doing something very similar in terms of having the CI part of CI/CD handled by the source control vendor, and then the CD by code pipeline, which, you are splitting responsibility, and you have to learn two different sets of tooling in terms of how to build these pipelines, and it makes it quite an awkward thing to explain to the dev team why you've done it like this. Why don't we just do this all over here or all over here? Kind of splitting that benefit.
That's right. I mean, I'm a big fan of GitHub Actions and Circle CI. I think they're both brilliant tools that I really enjoy using. They're a pleasure to use in comparison to code build and so on. So and also you buy into an ecosystem. You're buying into the team's experience and what they've got to use. GitHub Actions, there's all sorts of really cool stuff there, like like OWASP attack proxies and things like that. You can just use to test your code in different ways that are a little bit more difficult to achieve if you go over to the AWS side. So it's more about sort of benefiting from that ecosystem. So I think, but at the same time, as soon as you're talking about AWS credentials that basically have administrative access over your infrastructure, you don't want to hand that over. You want to keep that as close as you can to the AWS infrastructure. So I think it does make sense to use S3 as a sort of conduit for pushing builds over. But you're still giving a lot of trust out to the engineering team, though.
You are.
And
I have. Sorry, Ben.
So I was just going to say, I think one of the challenges that there is around all of that is that we're now kind of empowering these development teams to take ownership of so much more. It's not just building the applications and building code anymore. It's taking ownership of the infrastructure, looking after security, looking at your CI/CD pipelines and how your considerations are around that. There's a journey that I think teams need to be brought along in terms of getting them from potentially where they are now, whether that's enterprise applications development or anything like that to this kind of full-fledged DevOps mindset where they are empowered to do anything and everything. Some people just don't want to go there. It's like, well, I've spent my whole life being a Java developer. Why do I suddenly now need to worry about my infrastructure and, you know, how this stuff's going to scale elastically and what managed services I'm going to use and what their, you know, what the constraints are around all of that. So there's definitely some challenges around that, I think. Hearts and minds battle.
Is that a bit like, do you remember when unit testing became a thing, and suddenly you're asking people to write unit testing, and they go, "I'm not a tester."
Yeah,
like as if writing the unit test was beneath them somehow.
DDD. I just want to write code.
Yeah. Is it not the same battle again? Is it the same arguments?
I think there's a lot of overlap in there, and I think it's around this embracing DevOps culture and getting that understanding of what DevOps means to people. As we mentioned earlier, in some capacities, that's a team, which I think is opposite of the intention of DevOps culture. But yeah, it's not getting people to think of it as more ownership, well, more responsibility and more accountability, and you know, they're on the line for making sure all of this stuff works. It's selling people the dream of being empowered and giving that agency to kind of build whatever they want, however they want it, and making sure that that's the message that's communicated with people. It's that we are bestowing upon you this ability to build the right thing in the right way, as opposed to being confined, you know, by historical traits of, yeah, you chuck all your code across the wall and someone else will take care of it for you.
I mean, that's a huge inference on a management shift, isn't it? I mean, because what we've really seen over the last, or certainly what I've seen over the last 5 years, is a huge shift away from, I guess, traditional IT type led development. So you could kind of typify it from when I first started in the industry, it was very much big specification documents, broken down, and my job as a developer was to implement the specification as laid out by the architecture and the business analysis team. And so my job was to go through that, tick it all off, and then pass it over to the tester who would validate it against the same specification that I'd seen. And you know, that was okay. And then we sort of started doing things like Scrum, which was really kind of, I guess, back in those days, spiral development through the Microsoft RAB and all this kind of stuff. But they were all kind of shortening the cycles, but it was very much kind of business requirements led, you know, and this idea of IT and the business. And I think what we started to see is the shift into digital teams, where we're starting to think about, you know, teams are not part of IT. That, you know, development is not part of IT anymore, is it? It's generally part of a digital team that looks after customer acquisition channels or particular elements of a customer journey and so on. And I think what we've done there is now the team are wholly responsible for a customer journey or for a customer acquisition channel or in some cases a business process, if you like. But it's not. But the team's responsible for it, and they're a long-standing team. It's not. You know, your job isn't to be a developer anymore, is it? Your job is to look after a business process or try or achieve a business outcome. It's a different task, I think, than it used to be. And I think that's a good thing. But it requires a whole. Yeah.
It requires a whole shift in almost funding models, though, because you're not working in projects anymore that are just sent to a team for execution and then they're done, and then there's a new project. It's got to be as you say, a long-standing team with perhaps an annual budget whose only metric is that they continue to maintain and deliver on and improve this part of the domain that's their responsibility. And that requires a release of more fine-grained control at some of the executive level, where you're not signing off on the individual deliverables to the same extent as you maybe are in a traditional setup.
So you're saying that there's no transfer into support like there perhaps used to be, right? You might do a software release, look after something for a couple of weeks, you know, the hypercare period or whatever you want to call it, and then you do a handover into the support engineers, and then they have to look after it for the rest of its life. And that was always a pretty fraught process. You know, who would want to be a maintenance programmer? A very thankless task.
Well, that handover as well, I've always found spawned a great deal of bureaucracy and perhaps not necessarily unnecessary documentation, but perhaps process built out of concern for past incidents that maybe is not that valuable. So perhaps there was a piece of knowledge missed in a release 3 years ago that now means you have to fill out this extra bit of form every time a ticket goes from build into support. And this kind of builds up, and there's this reluctance to unpack any of that. And suddenly when you've got one team or one group and running it end to end, there's no need for that transfer, and you can keep the documentation that's actually valuable to the running of the product.
Makes sense. I remember working at a team once, and we had a sort of CI/CD pipeline set up before it was fashionable. That's right, I was a developer hipster, and a new IT manager came along and he was like, "Hey, whoa, we're not having developers releasing things to production. That's not going to happen. Not in my watch." And so he made us make installation packages for all of our software, so that the IT folks could run the installer and then run the uninstaller to do the migration processes. But there was something like 20 installers that they had to run on a release date. So it went from being a completely automatic process to being, okay, you now have to run these 20 installers in exactly the right order and make sure you do all these backups and all these other things. Needless to say, it lasted 2 releases, and then he's like, okay, let's go back to what you were doing before. Biggest waste of a couple of months ever.
And it's the fact that the people running those installers have no context as to how that software was built, so they're just kind of trusting those instructions, and if something does go wrong, then they're really not in a good place to work out how. So
you have to run them in an installer at that point and just hope.
Just back it out.
Do we think Lambda and all of the new AWS managed services and everything else, do we think that they can be supported by a business model which still encourages the notions of like support teams and project-based teams as opposed to
I think in some respects, like having a managed service lends itself better to that model, because you've got much less to go wrong and much less to look after. The maintenance tasks are vastly reduced. So you're able to, if you like, hand over much more, because what are you really handing over? You're saying actually AWS is responsible for all of that, and you're responsible for this code that runs in this, when these events happen. Monitor this with your CloudWatch dashboards that we built for you, and what else is there to look after? If it breaks, well, hopefully the lambdas will retry a few times, and you've got some dead letter queues and stuff like that. But it should be a reduced conversation, really.
So thinking from a Lambda specific perspective, if we've got, say, functionality that's now been broken down into composable functions, which is typically, I don't know, 5 or 10 times more than the amount of microservices that a support team would previously have to manage. Do we think that is something that could be supported by a team that isn't necessarily as close to the code as the product team would be, if they now had to manage 100 or 200 lambdas as opposed to a couple of 10 to 20 microservices?
I think as soon as you put a transpiler onto JavaScript code, or as soon as you use a compiler on your other code, you're so far away, aren't you? At that point, you're basically having to look at the code if you want to see what's going on. And hasn't that always been the case, really? What options do you really have? If the performance sucks, then ultimately you're going to end up looking at log entries, or you're going to end up looking at other insights that you've got. And if you've got nothing, you're going to go back to what we've always done, which is adding console.log into your code so you can see what's going on.
Nice. We've covered quite a lot of the topics, really, haven't we, from what we've discussed today. I mean, we've delved quite a bit into this more the security side as well, haven't we? Do you want to maybe go into that a bit further, or do you think we've covered most of it on that side?
Yeah, I guess at a pharmacy, I was did a lot of work on having security audits done there, because we're dealing with such a large quantity of healthcare data about patients. And as you can imagine, that it was the first cloud project too, the first thing that ever launched into any cloud service. So there was a huge amount of nervousness around what are these folks doing? Is this safe? Is this sane what they're doing? They're about to pull this information into the cloud. And what we did find was that the security teams and the people we talked to were set up for a different world than what we were in. So they were asking things like, how do you patch the operating system? Well, we don't. And how do you SSH into the machines? How do you do remote administration? And the answer is we don't. How do you check the patch levels? Well, we don't. We run these automated tools on our build processes, which tell us when our libraries are out of date, and we actually get automated pull requests, and they update our dependencies for us when it's time. And it took us a lot of explanation around what the serverless model was and how it worked, but ultimately it gave everybody a lot of confidence in the design, because if you start to look at things like API gateway and you say, well, we've not just picked something off the shelf. We're using API gateway as the entry point to all of our HTTP traffic. And you say, well, how do you make sure that it's secure? Well, it doesn't even support encrypted connections by default. AWS look after the TLS certificates for us. We don't handle the private key material. They choose the encryption parameters based on their understanding of best practice. So as long as, if you think that I can choose encryption parameters better than AWS, then sure, hand me the responsibility to choose the right kind of, I don't know what the right kind of curve is for elliptic curve cryptography right now, to be honest with you. I'm not that into it. I'm not sure. I'm a bit fuzzy on how many bits equals, different types of encryption algorithms, based around that stuff. So, I'd much rather hand that over to AWS than spend some time researching that stuff into the depth that I'd really need to do. And then you go a bit deeper and you go, well, okay, in a typical website, you would have a HTTP load balancer and it would hand off to the web server. So, but here we've got API gateway. It's already doing layer 7 load balancing. We've already had DDoS protection from AWS. We've already had rate limiting from AWS. They've already checked that our HTTP requests are valid. They've introduced 30-second timeouts. They've done a whole lot of the work for us. And then there's an encrypted connection between the load balancer and our web and our Lambda, which we would have had to do ourselves. So we've saved ourselves yet more work. And then you've got these kind of hard timeouts and which reduce the possibility of dwell time. And the more you look into it, the more you go, this really makes a lot of sense from just the security's perspective. The number of questions that it answers for you is really strong. And I think if you can avoid a VPC, having a network, then you solve a whole bunch of other questions around, well, how are your firewalls configured? Well, actually, we don't run any firewalls because we don't have a network. Oh, you don't have a network. Where does this stuff run? Well, it runs inside AWS, and we don't really have to worry about that so much. And and things like the AWS IAM, the identity and access management, it's really good. Like that kind of granular control. We don't have any static credentials anywhere. We don't have any passwords hard coded. Like there's no connection strings. Even if you're using things like relational databases with Secrets Manager, you can get it to get that to automatically rotate the credentials for you. We're in a really great position from a security point of view. So our main risks now are misconfiguration and automated exploits, which are looking for those misconfigurations. So now it's about automating as many of these kind of tools as possible along the path, and I think that's where I'm spending, I guess, more of my efforts, is making sure that the basics are in place from the landing zone point of view, and then making sure that the automated analysis is in place, and that the responses to issues are really solid. But yeah, like always, developers, they're the ones writing the code. There's only so far you can go. You look at the OWASP Top 10, it's not shifted much in the last 10 years, has it? It's not like it's a new bunch of threats. It's the same old stuff we've been dealing with for a long time. So there's still a lot of work to do there, perhaps.
Nice. Anyone else to add to that on the security side, or?
I guess the buried in, I think Adrian pretty much covered it, but I think one interesting bit is that the surface area, even if you take away whether you or Amazon is hardening the assets that your code is running on, or the API interface itself, if you've got a Lambda that's so ephemeral, it spins up, runs the code, and then is gone. There's nothing really to exploit. There's nothing to load malicious code onto that isn't going to vanish when your execution is complete. So it's just another dimension in which the surface area for attack has been greatly reduced.
Yeah, that's right. So if you exploit a web server and you're able to get something running, then it's sat there running for hours potentially, right? Like spinning around for days, doing more and more damage on quite a powerful piece of machinery. I guess the risk now is, if you configured your Lambda function with excessive privileges and it's able to leverage that to do more. So it's really about kind of keeping tight control on those policies, keeping an eye on that. But I mean, our organizations at that level, I don't think a lot of them are, right? In a lot of organizations, that we're still seeing people just doing a yearly pen test. It's like, a yearly pen test in a world where we're releasing several times a day isn't really working for us as a group. And these days, places like GitHub and AWS IP address space is being scanned constantly by attackers, just constantly with automated attacks that are up to date. The hardening has to be at a process level. It can't be sort of something that you do manually later on. It's about sort of reducing the risks in your process.
Okay, yeah. I mean, we've covered quite a lot there. I think we've been on for well over nearly an hour and 20 now. So I guess we've covered quite a lot in terms of serverless. I know we could go even further, couldn't we, really, in terms of serverless, because it's so much to talk about. But I guess, is anything else from you guys which you want to kind of bring up, which you've not necessarily covered so far?
Our sales pitch. So did you know that you can hire us to do a well-architected review of your serverless architecture? So we'll come. We're InfinityWorks are AWS partners, and we can do well-architected reviews for people who are using AWS to build serverless apps. And we'll do that for free for organizations. In fact, AWS will even potentially give you up to $5,000 of service credits for us to do follow-on work to help you improve the architecture of your systems. That's something that AWS offer as part of the partnership deal. So you can actually get some of our time for free. If you're interested in serverless, or if you're interested in adopting serverless, quite happy to talk to people and have a chat with them about what their designs are and give some input there through that program.
Nice. Okay, great. Well, yeah, I guess that's all this week for the Trusted Tech Talk Serverless podcast. Obviously, thanks for your time, Adrian, Calum, and Ben today for sharing obviously your experience and knowledge with working over InfinityWorks. And thanks everyone for sort of listening in as well. So yeah, we'll be back soon with some more sort of insights into the world of serverless. So if you have any topics you'd like to hear about, feel free to get in touch with myself or Trusted Tech Talks on LinkedIn, or feel free to drop me a message as well. Until then, take care and keep your eye out for the next episode.